Okay, so we have here a diagram, no? For us to identify what are the internal forces in our beam. Okay, so for figure 1, the internal force, no, can be determined by plotting our shear and moment diagram, no? So the magnitude of the internal forces, no, and these are the shear and the moment, no? So those are the internal forces. Okay, so once the beam is with external load, it will have what we call internal forces. Okay, so by plotting your shear and moment diagram, you may able to determine at different location from your beam, no, you may able to determine your shear, your moment, no. So hindi ko na elaborate to, you are already familiar, no, how to your shear and moment. Now another way of knowing our internal forces, if we will cut if we will cut our beam like in figure 2. So if we will cut it at section A and consider now the left part, no? So consider natin yung left part and we will draw the free body diagram. So in the free body diagram, it shows here your external forces. What are the external forces? Your reaction here and your loads here, no? Yung downward concentrated load. Now to make our system in equilibrium, okay, so at the cut section, there will be now here what we call your internal forces. And that includes what? Your and your moment. Now, if you will consider the other part, no, yung right part niyan, okay, also at the cut section, you will have your internal forces. And if we will compare it to the left part, in terms of magnitude, pareho lang yung dalawang yan kasi isang location lang. Now, in the free body diagram, they only differ in direction. Your shear on the right side, right part, it will be upward, while on the left part, it will be downward. Your moment also, no? So, clockwise in the right part and counterclockwise on the left part. But at the cut section, okay, you only have uh, one internal forces, no? Okay, your shear and moment, considering the left part and the right part, no, you will only have you will have the same, no, internal forces, just like what is shown dito sa figure B. Okay, now if we will consider now a differential length in our beam, no, so cutting our beam at section A and at section B, no? So pag kinat mo yan, having a differential distance dx, no? Ito ngayon yung ating free body diagram at C. Okay, so at the left section, your internal force there are V and your moment M. Now onto the right side, which is at cut section V dash B, your internal force will be B. Okay, your shear is V acting downward, no, so that your system will be in equilibrium. And then your M, if you're going to look at your M here, your moment here will be what? Will be M plus dm. Your internal moment here will be M plus dm. Now, why is it you have plus dm? Because of what? there is already a change in moment due to the distance dx. That is the effect in terms of moment. Now, if we are considering a differential distance, your shear will not change much. Hindi yan masyadong magbabago, no? Kaya yung shear natin dito, same ang magnitude. Okay? So yun yung difference, no? Between M plus dm. Okay? So that is about the internal forces. Okay? So later on, no, makikita uli natin ng mga yan, no? Okay, so for the next slide, okay, considering now our horizontal shear stress, no? Okay, we have here two unloaded, no? Unloaded stack of slab, no? So itong letter A at saka letter C. Yung letter A, yung stack of slab natin are actually what? They are for each slab, no? They are not glued, no? Hindi sila naka-glue. So basta pinatong lang sila, no? While at letter C, yung ating stack of slab naka-glue, no? Naka-glue ang mga yan, no? So glued yung slab natin. Dito unglued siya, no? Okay, once this are loaded, no, itong mga stack of slab natin, yung letter B figure, makikita nyo, no, how the stack of slab behave once the payload is applied, no? So magi-slide ang bawat slab, no? So nagi-slide, nagkakahiwa-hiwalay sila, no? Whereas dito sa glued slab, okay, they remain intact sila, no? And what we notice here is that the stack of slab, no, resist the load para hindi magkakahiwalay yan. And the glued part, yung sa glued part, okay, yun ang nagre-resist ngayon para hindi magkahiwa-hiwalay yan. And the glued part is actually under shear stress. Okay? Para hindi magkahiwa-hiwalay, no? So therefore, yung stress na nadidevelop, no, between contact ng mga stack of slabs is actually a shear stress. And the shear stress is developed in the glued part, no? So yung glue mismo, okay, ang doon na di-develop yung ating shear stress, no? So yun ang nagre-resist. Okay, whereas dito sa unglued wala, no? So walang magre-resist dyan. They simply what? Yung mga stack of slab natin, they will simply slide one another, okay? Okay, so yun yung about this figure, no? So ibig sabihin, no, when you have a beam, no, and it is loaded, okay, at different depth, no, at different we can say it distance, no, or at different distances here along the depth, no, a shear stress is actually developed, no? Merong stress na nadi-develop dyan, no? So if we will consider this as a whole section, so ganito rin ang behavior ng ating section, no? Kapag buo yan, no? So there will be stress developed at different depth dito sa ating section. Okay? So yun ang gustong i-point nitong figure na to, no? So therefore, no, if there are stress developed, we can actually determine those stresses by making use of this formula, no? So FB is the shear stress, shear stress in the member at point, no? By the way, no, itong FB na to in this legend, no, is actually equal to tau, no? Tau ito, no? It represent the shear stress, yung ating FB. So this is the shear stress in the member at the point located y prime from the neutral axis. So yun, no? So if you're considering this section, okay, you're looking for the shear stress at this line. At this line. Okay. So all you need is make use of this formula, no? Wherein V represent the internal resultant shear force. Saan mo kukunin yung V mo? Dito sa beam. At a specific location dito, no, you get your shear. So ibig sabihin mag-shear diagram ka, no? Okay? Mag-shear diagram ka. So there's a specific shear on a particular location on your beam. So common dito ang ginagawa natin. We consider the critical part. Ano yung critical part? Ito kung saan yung maximum shear dito sa beam mo. And that represent this shear here, no? V. Okay? It is the internal force in your beam based from the loading. Kaya nga dito sa introduction natin, no? Ito, no? Paano natin makukuha yung internal shear? One way is shear diagram, or you cut at a certain distance, you get the free body diagram, or you must have your free body diagram for you to get the internal shear force on a particular section. Ngayon dito, if you want to draw the shear diagram, you can also get that internal force, no? So yun yung internal force P dito, no? So now yung Q naman, so since we're looking for the shear on this particular location, no? Okay, which is y prime from the neutral axis. So yun yung distance niya from the neutral axis. So what we need is, we need to get Q. And what is Q? Q is the first moment of area about the neutral axis. So this shaded part, okay, itong shaded part na to, that represent the area that you're going to use, wherein itong area na to imo-moment mo with respect to the neutral axis. Okay, its moment arm will depend on the centroid. Okay, its moment arm will be referred from the centroid of this area. Kung anong centroid nito, hanggang sa neutral axis, yun ang kanyang moment arm. So that is known as the first moment of an area, no? So you get this area which is above the point where you're trying to get the shear stress, no? So itong shaded part na to. Now it will be divided by I. No, yung I natin is the moment of inertia of the entire cross-sectional area, and that is the moment of inertia with respect to the neutral axis. No? So with respect to the neutral axis, yun yung I. And then B is the width of the member cross-sectional area at that point, no? So kung ano yung B mo dito, kung ano yung width ng section mo on this line, no? Yun ang magiging B mo, no? So ibig sabihin, at y distance, y prime distance from the neutral axis, what will be your B here? No? That is the width of your B on that line. So that is how you make use of this formula. So ibig sabihin, at different y distance from the neutral axis here, makakakuha ka ng mga stresses, shear stress, making use of this formula. So that, no? Wala na ba dito? Tignan ko lang. So that, no, when you plot now, no, actually ito yung kadugtong nun, no? Para at least ma-imagine natin. So for a rectangular section, this is actually the diagram. No? Ito yung shear diagram. No? Kapag kumuha ka ng different y distance from the neutral axis, you are actually plotting yung kanyang shear diagram. No? Ito yung shear stress diagram. No? Ito, no? It's actually parabolic, no, in shape. Okay. Now, for a wide flange beam, this is actually the shape. Ito yung shape ng ating shear stress diagram, no? Okay. So, yun yung about that shear stress formula, no? So, you can actually determine the shear stress distribution with respect to the cross section. Okay? So, yun yung about this one, no? Okay. So, that is how we make use of this, no? So then, if we will consider, no, the horizontal shear stress, no? Okay, so ito, no? Itong mga stress na kinukuha natin dito is actually the horizontal shear stress, no? Now, if we will consider an element, no? Dahil itong element na no, napakaliit lang, no? Napakaliit. No? Infinitesimal yung kanyang dimension. Okay? So, when we consider an element here, so there will be a shear stress at the top of this element. That is the horizontal shear, no? And then, since napakaliit nito, no? Okay, infinitesimal yung kanyang dimension. No? Yung shear stress mo at the bottom of this element is actually equal in magnitude as the top, only opposite in direction. So, ganun yung considering an element. No? You're talking of an element, no, and considering horizontal shear stress. Okay, so that is about this one. Remember that this horizontal shear is computed using this formula. Okay, and I have shown you already how the shear stress distribution for rectangular and for a wide flange, no? Okay, so since, no, dahil as I have mentioned that this is, the dimension of this is infinitesimal, pag infinitesimal, no, napakaliit niya, no? So we can also say that the vertical stress, shear stress, no, of this element on the right side of this element is also equal to FB. And similarly, ganun din dun sa left side nung ating element, no? So this is now the diagram, no, of the stress acting on an element having an infinitesimal dimension. Okay? So pare-pareho on all sides yan, no? Yung ating shear stress. Okay, so if we will consider the three-dimension, okay, a three-dimensional drawing of this element, eto bali yun, no? Okay? So the shear stress is acting, okay, along dun sa apat na sides nitong element natin, no? Okay? So I already shown you this. Okay. So let us consider now Okay, the stresses, no? Other stresses develop do sa ating beam if it is subjected to a load, no? Pag subjected yan sa load, and for this given beam, it is subjected to a vertical load, no? Subjected to a vertical load. So, ang beam natin, pag may load na ganito, it will bend. Magbe-bend yan, no? At ang bending natin ay concave upward. So, concave upward. Pag concave upward yan, yung pinaka-top is under compression. Yung pinaka-ilalim will be under tension. While yung, if we will consider the neutral axis, no, representing this center element. So the neutral axis, it has no stress. Yun yung about the neutral axis. So therefore, if we will look at the element at the top of this beam, okay, so since it is under compression, so ito ngayon yung direction ng ating forces, no, on the element. And the computation of the stress, of the bending stress, is equal to MC over I. I hope you still recall your lesson in mechanics of deformable bodies. So merong derivation ito, no? Itong flexure formula. We call this as the flexure formula, no? So MC over I. Yung moment is actually the moment at this point. So meaning yung moment diagram mo. Yun ang gagamitin mo on this particular point. And then your C, that will be the distance of the that is the distance of the the extreme compressive fiber up to the neutral axis. Yun yung C. And then I representing the moment of inertia with respect to the neutral axis. No? So yun yung ibig sabihin nito. Now at the bottom, the part here is under tension. Kaya kung i-consider natin yung isang element dyan, so the forces acting on that element will be tensile force, no? So yan. Okay, and the stress is a tensile stress. Again, using the flexure formula, we have the formula MC over I. So yung C natin dito will be the distance of the extreme tension fiber up to the neutral axis. No, yun yung C natin. And it is divided by the moment of inertia with respect to the neutral axis. Okay, so that is about the determination of the stresses on a beam when it is subjected to a load. Okay, so yun yung ating bending stress, no? By the way, this formula, no, bago tayo lumayo, is applicable if your beam behave elastic, no? Okay, so if your beam behave elastic, no? Anong elastic? Okay, when a body, no, is subjected to a load, and the body will deform due to the load. Once the load is removed, the body will return to its original shape. That is all about elastic behavior, no, of a material. Okay, for the shear, ito naman yung shear, no? Pag shear naman, at this point, no, our element is subjected to equal magnitude, no, of shear stress. No, if you are considering an element, okay? And the computation of the shear stress, making use of this formula, no? VQ over I multiplied by T, no? Or the width. Yung B dito, B minsan ang ginagamit, ha? Gaya ng unang formula natin. Okay. So if we will combine now the two, pag kinumbine natin yung dalawa, pag kinumbine na natin, by the way, ano pa pala yung na-notice natin? Balik tayo dito, no? Balik tayo dito. Very important din ito na malaman natin, no? With regards to the shear, no? With regards to the shear, ang shear natin is 0 at the top and bottom. No? It is always 0 at the top and bottom if you're talking of a beam, no? Okay? Pag beam ang pinag-uusapan. Mayang sa ano naman sa bending stress naman, maximum in compression at the top, maximum in tension at the bottom. No, 0 at the neutral axis. So, ganun naman ang behavior ng stress. Okay, that is why here, okay, yung element na kinonsider, it's not at the top, it's not at the bottom because your shear there is 0. So it is considered somewhere here, no? And then if we will combine it, no? Combine the bending and the shear, considering an element here. Remember that our element now here, if we will consider bending stress, is under tension. So that is why your bending stress is actually a tension stress, no? Or a tensile stress, sigma x. Ayan. Now for the since this one is not really at the bottom, so it is somewhere at the tension side. It is not really at the bottom, but rather at the tension side. So there will be tensile stress on that element. So ito yung combination natin. Okay, so I hope nakaka-follow kayo, ha? Okay, so how about considering an inclined surface or an inclined plane? So how do we determine the shear, no? Okay? So pansinin uli natin. Okay? Yung ating tensile stress is perpendicular. Our tensile stress is perpendicular to the section, no? To this element, no? To the surface of this element. While yung shear natin is parallel. Okay, it is parallel to the sides of this element, no? So ibig sabihin, kapag kumukuha tayo ng bending stress, okay, it is always perpendicular, no, to the surface where it is acting. While if it is a shear, it is always parallel. No, the shear stress is always parallel to the surface kung saan siya nag-act, no? Okay, so again, look at the behavior here, no, kapag incline. Okay, kapag incline, yung plane natin, ganun pa rin naman yung ating normal stress at saka shear stress, no? By the way, they call this as normal stress, no? This one is called as the shear stress. So in an inclined plane, even though if the load is still vertical and we are considering an inclined plane, no? Considering an inclined plane, dito kasi puro horizontal, no? Plane at saka vertical plane ang kino-consider natin. How about an inclined plane? So how these stresses are acting? So pareho din naman na yon. Yung normal stress natin, perpendicular pa rin sa surface kung saan nag-a-act yung ating stress. While yung shear stress natin, parallel pa rin. So walang effect, no, kung inclined, horizontal, no? So the way the stress develop ganun pa rin yung behavior niya, no? So, parallel sa shear, do sa surface, perpendicular naman sa normal stress. Okay, so if we will consider now the original state of the stress, we have this one, no? Okay, so the normal stress acting on the x-axis, designated as sigma x. On the y-axis, we have sigma y. And then we have our shear stress acting parallel, no, to the element, no, surface. Okay. Now, if we will transform, okay, considering a transformed axis, no. Okay, so yung ating mga stresses, ganun pa rin naman ang behavior, no? The normal stress still acting normal or perpendicular, while the shear is still parallel yan, no? Parallel pa rin. Okay. So yun yung ating yun yung behavior ng ating mga stresses, no? Now for principal stresses and principal plane, okay, ito yung difference nila, no? Okay, so for the original state of stress, we have this one. Now pagdating dun sa principal stress, sigma 1 will be parallel, no, or it will be perpendicular to the surface, and sigma 2 will be still, no, perpendicular. Okay, so considering here sigma x and sigma y, so in terms of the principal stresses, so ang mga stress natin are acting perpendicular surface to the surface of the elements, no? Okay, so ganun kapag principal stresses and principal plane, no, ang pinag-uusapan. So they are always perpendicular to the surface of the element. Okay, so let us consider now okay, let us consider now this beam, no, under elastic, no, stage. Okay, so if we will consider here the combined flexure and shear stress to sa element. So at the top here, it is under compression. At the bottom is under tension. Kaya makikita mo yung ating normal stress toward the element because it is under compression, while at the bottom side, okay, or under the tension side, the normal stress is acting away from the element, dahil tension. Okay, now if we will consider principal stress, no, we will consider principal stress. Ito yung magiging direction ng mga stresses natin, no? Okay, so here at the for this element, no? So for this element, okay, so itong part na to, no, mapapansin nyo yung ating stress on this axis, okay, it remain tension, no? Tension pa rin, no? So makikita natin, no, tension, while this one is under compression, while yung vertical principal stress natin, no, so I'm assuming this is the horizontal, no, and this is the vertical. So makikita nyo baliktad, no, baliktad yung direction. So at this element, it is in tension, while this one is in compression. Okay? So, yun yung magiging direction ng mga stresses natin. Okay? Acting on an element considering principal stresses. Okay? So, very important ito pagdating dun sa determination, no? Determination ng behavior, no? Behavior ng stresses sa isang beam, no? If you are considering a beam and considering the behavior of concrete, if it is subjected to a load, no? So this is actually a beam having no reinforcement, no? So this is how the stresses in the concrete behave, no? By looking at this element. So at the top, on this direction, it will be in compression, but on the vertical direction, it is tension. While here, on this direction, it is tension, while here it is in compression, no? Okay, so those direction of the stresses can be related to this one, no? So that is actually what the behavior of the concrete, no? So this is obtained when they done experiment, no? Wherein they subject, no, a concrete beam, they subject it to a vertical load acting downward, and they observe, no, what is happening to the concrete, no? Okay, and they notice this one, no? Okay, they notice the cracks, no? The direction of the cracks, the behavior of the cracks, no? Okay, look at here, no? So the cracks are diagonal, no? And they are what? If you notice, they are somehow, no, converging kung saan mo in-apply yung load. Then by plotting, no, this what we call the trajectory of the stress, no? By plotting the trajectory of this stress, this is this trajectory of the stress, this is actually the direction, okay, of the cracks that develop, no, when they test a concrete beam, no? Itong concrete beam na to walang reinforcement. With longitudinal reinforcement only. Wala siyang stirrups. Walang stirrups, no? So they want to know, they want to see what will happen to the concrete once it is subjected to a load. They notice this behavior or this direction of the crack, and by analysis, they notice that when they plot now, okay, when they consider the principal stresses, okay, in the concrete, no, okay, they notice this part, no, look at here, no, itong line na to, itong line, no, which is what, direction nitong principal stress na to. Okay, so what you notice here is that the stress here is in compression, and the direction is diagonal toward this direction, no? And look at this upper part. Yung diagonal line mo dito represent also this direction or trajectory of this principal stress, which is in compression. Okay, ito, no? At saka yun. Okay, so if we will plot this trajectories, we have this one. Ito yung trajectory ng compressive stress. Okay, based from this principal stresses, no? So this is the trajectory of the compressive, and they saw it that it is similar, no, to the trajectory of cracks. Now, pag nag-crack yung concrete natin, anong nangyayari? Bumubuka yan. Due to what? Due to tension, no? So ito. Okay, look at here. Pag nag-crack yan, yung principal stress natin dito is actually in tension. Look at that, no? Kaya bumubuka yung konkreto natin, no? Because of the behavior of this principal stress. So here, kaya may crack ka dito kasi under tension din to, no? Tension yung trajectory. Okay? Tension yung stress natin dito. No? Tension. And also here tension, no? Kaya na-form itong crack. No? So by plotting the trajectory of the compressive stress, okay, this trajectory is under what? So the concrete here is actually or perpendicular to this trajectory, to this compressive trajectory of stress, is actually what? We have the principal stress that is a tensile stress, no? Kaya yung ating concrete nagka-crack. So that is about why cracks are formed, no? Cracks are formed, no? And why is it their direction is diagonal? Okay, because of this, no? So ito yung kanyang pinaka-theoretical, no? This part now, this plotting of the compressive stress trajectory is actually the theoretical part. Theoretical part, why is it? No, when you test your concrete, no, why is it it has a crack, no, coming from the tension side, and why is it the cracks are diagonal? Because of this, no? Ito yung pinaka-theoretical part niya, no? So that's basically what we are trying to what I'm trying to discuss here, no? Para maintindihan nyo yung theory behind why is it the concrete cracks, no? And why is it the direction is diagonal? Because of this, no? Okay? So then, no? Okay? They done additional testing, no? Ganun lahat ang dating ng mga cracks, no? Ano yan, no? Diagonal, no? And the cause of the crack, no? Iba-iba yung cause niya, no? Pwedeng flexural, pwedeng combination ng web and shear cracks, then also combination ng flexure and shear. So what we notice sa flexure and shear is that the crack will what? The crack start at the bottom, and that is due to flexure. And then at the web, no, ito yung pinaka-web ngayon ng ating okay, pinaka-web ng ating beam. So yung cracks na nadidevelop dyan, if you're going to look at it, no, it is diagonal in direction. So this is due to shear, no? Okay, so this is due to shear. Okay, so yun yung about combination, no? Combination of web and shear and combination of flexure and shear. Pag web naman, web and shear, yung crack mag-occur lang sa web. Doon nag-start yung crack sa web. And it is diagonal, kaya kino-consider yung shear, no? Okay? So remember, the crack is due to shear because yung pinanggalingan nitong mga principal stress natin, okay, we derive it considering the flexure and the shear stress. Okay? And the shear stress representing what? Representing the vertical here, no? Okay? Kasi nung kinonvert natin dito, yung ating normal stress representing that sigma 1 and sigma 2 representing the shear, no? Okay? So then, no? Okay, ito ngayon yung ating pinaka-trajectory or pinaka-theoretical background why cracks develop on a concrete without shear reinforcement, no? And the cracks are actually diagonal, no? Okay? So lahat yan, no? Yung theoretical background niya, pinrove nila through tests. Okay? Yan, no? Test. But actually, it start with this. No? Na-observe nila bakit ganyan yung mga cracks. Then eventually, through analysis, no? So, dito nila na-derive o dito nila na-establish yung theoretical background niya, no? Why is it the cracks are diagonal in direction, no? Okay? So, ito yung ating iba-ibang identification ng cracks, no? If your crack start at the bottom, which is under tension, so this is due to flexural cracks, no? Okay? Now, if the crack, no, it's not, if the direction of the crack, no, is diagonal, so we call it as the inclined crack. Okay, inclined crack yan. Okay, so eto ngayon yung purpose ng ating shear reinforcement. So if yung crack in the beam is like this, it's actually inclined, no? By putting a shear reinforcement like this one, a diagonal reinforcement, we can prevent. Okay, we can actually prevent this crack, no, na mag-occur or mag-develop. Okay, so just like also this one, if you have here a vertical or if you have here an inclined crack, you can also you can also resist this by putting a vertical reinforcement, no? Okay, we call it as vertical shear reinforcement. Ito naman incline, para maiwasang bumuka or mag-produce or magkaroon ng inclined cracks, no? Okay, so dito ngayon papasok yung ating tinatawag na design, no, sa shear, no, to prevent these cracks. Okay, so we put shear reinforcement. So the shear reinforcement can be inclined or it can be vertical. So meron isa tayong figure dito, picture showing here yung failure ng isang beam. Okay, papapansin natin yung beam natin, ang crack niya diagonal, no? So yung failure niya is more on the shear, no, rather than flexure, no? Okay? So kasi yung bakal mo dito sa bottom hindi naputol no? Hindi siya naputol, no? Okay? Ang nangyari, nag-crack yung concrete mo at ang direction niya diagonal. So meaning, okay, kulang ng shear reinforcement yung ating beam, no? Okay? Kaya naputol to, no? So hindi lang yielding, no, hindi lang yung main reinforcement ang mapuputol para bumigay yung beam. Pwede rin, no? Pwede rin bumigay, no, dito. Why, no? Kasi itong center dito, yung top bar mo dito, usually dito ka kakaroon ng tinatawag na splice kapag positive yung moment mo, no? So the splice is usually at the top, no? Okay, yung bottom reinforcement mo at the midspan continuous yan, walang splice yan, no? Walang dugtong. So nagdudugtong ka doon sa taas. So since bumigay yung nag-crack, no? Nag-crack yung beam natin due to what? Lack of shear reinforcement. So umabot siya doon sa part na merong splice. Kaya yun, bumigay yung ating beam, no? Okay, so let us now determine yung mga internal force. Okay, yung mga internal force sa beam natin, no? Without web reinforcement. Okay, so if we will let yung beam natin na mag-crack yan, ito yung ating mga internal force. Number one, we have this, no? The shear in compression, designated as BCY. Another one, along this diagonal cracks, you have your VA, no? Your shear. If we will resolve its component, okay, yung internal force na i-consider natin dito will be the vertical component. So that is the vertical component of the aggregate interlock force. So this is the interlocking ng mga aggregate natin. And then at the bottom, yung ating longitudinal reinforcement. So this is due to shear, no? Okay? So kaya meron tayong VD, okay? So VD representing the shear force that is parallel to the cross section of the main reinforcement or the longitudinal reinforcement. So those are the three shear internal force, no, dito sa ating beam. VCY, VAY, and VD. Okay? Yun yung mga internal force natin. No? Okay, so look at here. CZ is the shear in the compression zone. VAY is the vertical component of the aggregate, and VD is the dowel action from the longitudinal bar. Okay. Now, how about if we will put, no? So yung mga internal force na nabanggit kanina, yun yung mga shear force, no? Mga internal force na nadi-develop or the internal force in our beam kapag nag-crack yung ating beam, no? Okay? If it has a diagonal cracks, no? Diagonal cracks. Now, if we will put a shear reinforcement. Okay, we will put here a shear reinforcement. So the beam or the shear reinforcement, no, ito. Okay, yung kanyang force na mag-resist, no, doon sa crack is actually a tension force. Okay, so it's actually a tensile force, no? It's actually a tensile force designated by VS. Ito, no? It's actually a tensile force. Okay, so therefore, having now a stirrups or a shear reinforcement, our internal forces now, ito ngayon yung internal forces natin, VCY plus VD plus VAY plus VS, wherein VCY plus VD plus VAY are considered as V sub C. No? So those are the internal force due to the concrete, no, and due to the longitudinal reinforcement. Yung VS natin, this is due to what? Due to the shear reinforcement. So iniwalay natin. And the sum of this shear is known as VN. No? Okay, VN. Okay, yun yung ating designation. Okay, so what is now the use of or the function of the shear reinforcement or web reinforcement? The web reinforcement is provided to ensure that full flexural capacity can be developed. Okay, desired a flexure failure mode, shear failure is brittle. No? Okay, so desired a flexure failure mode because shear failure is brittle. Okay? So, putol kasi kagad, no? Okay, ngayon, lalagyan mo ng shear reinforcement wherein it will resist the stress developed, and that is due to tension, no? Kaya ang magiging failure mo is a flexure failure mode. Kaya flexural failure mode, not a shear, no? Now, yung ating shear reinforcement or web reinforcement acts as a clamp to keep shear cracks from widening, which is true, no? Okay? Pag nilagyan mo ng shear reinforcement to, okay, hindi madidevelop yung crack kasi yung ating shear reinforcement ipiprevent niyang bumuka yan dahil merong nagre-resist dun sa shear force na nadidevelop dyan, no? Or shear stress na nadidevelop dyan. Okay? So that is, this one serve as a clamp para hindi mag-occur to or hindi bumuka, no? Okay, so that is the purpose, or that is the function of the web reinforcement. Another function, no, aside from that, is the web reinforcement serve as a what? As a what we call it? It serves as a guide in positioning your compression reinforcement or your top reinforcement. Okay, without the stirrups, and even the not only the top, but rather yung mga longitudinal reinforcement mo, no? Para maiposition mo silang mabuti, you simply fix them on the web reinforcement. So that's another function of the web reinforcement, no? Okay, they serve as a what? As a guide for our longitudinal reinforcement para maiposition mo silang mabuti. Okay? So that is about, other function. No? Okay, so we have here actually three types, no, of web reinforcement. We have the vertical, the incline, and the bent up, no, bent up bars, no. Okay, so for the incline stirrups, okay, the angle or the angle of inclination, okay, we have 45 degrees. Now yung bent up, pag nag-bent up ka, the angle is usually 30 degrees, no? So these are the recommended angle of inclination. Okay, so in putting web reinforcement, pwedeng vertical, pwedeng incline, pwedeng combination ng vertical and bent up, no? So you may actually use that, no? Or you may there is also a web reinforcement in a form of spiral, no, sa mga columns, no, especially kapag yung columns mo circular, no, mga circular member. Pag circular member ka, no, circular yung cross section, it is better if your web reinforcement is spiral, no, nakapaikot, no, nakapaikot yan. Other web reinforcement, you may use welded wire fabric, no? So pwede rin yun. So ito yung mga possible arrangement, no, ng ating shear reinforcement. Okay, example of stirrups that you may use. This is given by ACI. So you are recommended to use this kapag ito, no? If you neglect torsion, you may use this. Kapag kinonsider mo yung torsion sa beam, okay, ito yung recommended stirrups natin, no? Or web reinforcement. Other they call it as shear reinforcement. Okay, so these are given by ACI. Now, I put here, no, specifically, no, for the analysis, because when I prepare this lecture, I make use of the ACI 318-2011. No, yun ang ginamit ko, no? So this is actually what is written in the ACI 318-11. And when I check this, I compare it to NSCP 2015 and I compare it to ACI 318-2014. No, pareho lang sila, hindi nagbago, no? Ibig sabihin yung NSCP, actually yung NSCP 2015, yung kanyang structural concrete, it is based from the ACI 318-2014. Doon nila binase, no, sa 2014 yung ating structural concrete, no? Kaya makikita mo kapag binasa mo yung NSCP at binasa mo yung ACI 318-14, yung 2014 na ACI, okay, pareho sila, no? Dahil yun ang inadapt ng NSCP, no? Yung ACI 318-2014. Okay, so pareho lang yung equation natin. No, basic design equation, we need to satisfy this, no? That the factored shear capacity at a particular section must be equal or greater than VU. Ano yung VU? Ito yung shear stress, no? Okay, yung VBN natin, ito yung factored shear strength. I'm sorry, no? VBN. VBN is the factored shear strength of the beam, no? Okay, while yung VU, it is the factored shear force at a particular section. Ibig sabihin ito yung maximum shear, or ito yung shear at a particular section dun sa beam mo. Okay? Okay? At a particular distance, X distance dun sa beam mo. Beam, ha? Beam. Ibig sabihin, makukuha mo to sa shear diagram. No, usually kapag kinumpare natin, to, we are talking of the maximum shear, VU. No? So tandaan natin, VU is coming from your shear diagram. Ha? Yung VBN, that is the factored shear strength of the beam. No? Okay? So for the strength reduction factor for shear, it is 0.75. Ha? Even in the NSCP, no? 0.75 din. So hindi ko na-update to. It is also equal to, no, same as sa NSCP 2015 and even the ACI 31814, no? Okay, so for the determination of the nominal shear strength Vn, ito yung formula natin, no? Vn is equal to Vc plus Vs, no? So, ito yung ating shear na in-identify dito, no? This is known as the nominal shear strength, and it is equal to Vc plus Vs. Now, itong Vc natin, which is equal to Vcy plus Vd plus Vay, no? Okay. Itong mga value na to, no? These are theoretical value, no? Mga theoretical value yan. Okay, ngayon, ang ginawa ng ACI, meron siyang binigay, no? Ni-recommend na value for Vc. And it conforms yung test, no? Okay? So ito yon, no? Okay? Ito yung equation natin. So how do we get Vc? ACI recommend this following formulas for Vc, no? So the attainment of this Vc is based from the test, no? And using a data, na-create nila itong mga formulas na to. Itong mga formulas na to are considered empirical because they conform results from experiment. Ha? Okay, so ito yung ating mga gagamiting formula in solving for Vc. Solving for Vc. Okay, so for shear and flexure, kapag yung beam mo, may flexure yan at may shear, ito yung pwede mong gamiting formula, no? Simple formula and detailed formula, no? Yung lambda natin dito for sand lightweight concrete 0.85, for lightweight concrete 0.75, for normal weight concrete 1.0, no? So ito yung dalawang formula natin. So this is detailed, no? Ito yung simple, simple formula. So merong condition dito sa detailed. Once you make use of this, it should be equal or less than this quantity. Kailangan masatisfy mo. Ngayon, yung VU D over MU natin, yung VU dito, kinukuha natin to sa shear diagram. Itong MU ganun din. Doon sa moment diagram. Ibig sabihin kung saan yung nag-occur yung VU, doon mo rin kukunin yung MU. So ulitin ko, kung saan nag-occur yung VU, doon din kukunin yung MU. As mentioned here, MU occurs simultaneously with VU at certain section considered. So again, ulitin ko, kung saan nag-occur yung VU mo, yun din yung location ng MU. So yan. Now, if we will get the ratio of this multiplied by T, it should be equal or less than 1. Now, if it is greater than 1, this quantity will be equated to 1. Equate mo na ng 1 kapag ang result niya ay greater than 1. No? Okay? But if it is less than 1 or equal to 1, yun ang magiging value niya. No? Okay, so compare mo dito, kailangan equal or less than. Kapag equal or less than, you may use this. But in case it is greater than, you may use this one. So that is for the detailed formula. Yung rho W natin is equal to AS over BD. So this is the rho, okay, for our so this is the rho of our tensile reinforcement. Okay, so yun yung about rho W. Okay, how about when your section is what, or your member subjected to shear and axial compression? Ito naman yung formula natin. So ito yung simple formula. It should be greater than 0, no? So kailangan, no, greater than 0 yan. Hindi pwedeng negative ang result, ha? Okay, yung NU natin, positive for compression. Ano yung value ng NU? Ano itong NU natin? It is the axial force. NU over AG must be expressed to megapascal, no? So the ratio. Okay, so yung ating formula ulit, no? Similar to this one, no? Dito sa with flexure. Kaya lang ang nadagdag ngayon ito, no? Yung condition na to nagbago, no? Nagbago to. Okay, nagbago yan, no? So kailangan i-compare mo, no? Marami kang i-consider dito, no? Number 1, MM, no? Kailangan mong makuha yung MU minus NU multiply by this quantity. Ha? Tapos BU over MU multiply by this shall not limited to 1.0. Okay, so if your MM is positive, okay, you may use this formula. But in case MM is negative, you may use this formula. Okay? Yan ang pwede mong gamitin. So, maraming kinukonsider, no? Okay, for shear and axial tension, for simple, wala formula, no? But for the detail, meron. So, tandaan natin kapag axial tension, NU is the axial tension and it should be negative. Ha? Pero kapag axial compression, NU must be positive. Ha? So, yun yung mga bagay na tinitignan natin. Okay? So, those are the different formulas used in solving for BC. Okay? The determination of BS, okay, if you have already your stirrups, meron ka ng stirrups, pwede mong kunin yung BS using these formulas, no? Okay, using these following formulas, ha? Okay? And then, sabi dito, BS based on assumption that the stirrups will yield. Okay, stirrups anchored, no? So, requirement ito sa stirrups, no? When considering BS. Okay, by the way, yung BS na yan, that is the shear force due to tension, no, dun sa ating stirrups, ha? Okay, when solving for the spacing, we need to test this following. Okay, in solving for the maximum spacing of stirrups, you need to compare this. Kapag yung VS mo is equal or less than 0.33 of this quantity, the determination of the maximum spacing of stirrups, ito yung i-consider natin. D over 2 must be equal or less than 600. Ibig sabihin, whichever is smaller of these two, siya yung magiging S max mo. Now, if VS is greater than this quantity, your S max is computed or is determined using these two criteria, D over 4 and 300. Whichever is smaller of the two, that will be your S max. Okay? Then also, we need to check also that VS is equal or less than 0.66, no? Multiply by this quantity. So it is a requirement that your VS must be equal or less than 0.66 of this quantity. Okay, for the minimum shear reinforcement, we have this formula. Lahat ito nasa CP. So you consider this formula and also compare it here. It shall not be less than this quantity. Pag mas maliit siya, ito ang i-adapt mo, no? So yun yung about the comparison of this. So this is just equations for us to determine, no, we call it capacity, no? So if we are trying to compare, no, the shear strength of our shear strength of our beam, compare it to VU. So this is how we solve PBN. No? So this is how we solve PBN. Remember that the nominal shear is VC plus VS. And for the vertical stirrups, this is how we solve VS if there's already stirrups. And then all you need is substitute VS here to make our VN equal to PBN. All you need is multiply these two by the strength reduction factor. So VC multiplied by reduction factor, and also VS multiplied by reduction factor. So this equation, for us to say na adequate yung shear reinforcement mo, it should be equal or greater than VU. Okay, so yun ang requirement. Ha? Okay. Bago ko ituloy ito, no, mag-break muna tayo. Ha? Break tayo ng 15 minutes. No? Balik kayo ng sige, balik kayo ng 2:10. No? 2:10. No? Okay? So balik tayo ng 2:10.